I'll explain what that means in just a second. Because here's the thing, Caleb, we do have the square root inverse function, right? So how do we get that? By restricting the domain. Is your eye okay? It is super red.
It's swollen. It's because I got some in and I just keep rubbing it.
Have you been to the optometrist to get it checked out?
No, I just got some in.
Okay.
Like today.
Oh, gotcha.
I don't know what I got. I think I put my hand on something, put my hand on my face and I got it. I mean, I only got one.
Fair enough. And so we want to remember, right, that the domain, is that referring to the x or to the y values? To the x values, right? So what is the domain of this original quadratic function?
Negative infinity, positive.
That domain would have been negative infinity to positive infinity.
So
But if I restrict the domain, what is the domain now, right? So I'm taking out all of this stuff. So it'd be 1 to positive infinity. And so that's literally what you would do is instead of looking at the entire parabola, you're only going to look from the vertex to the right, or technically you can look all the way from the left to the vertex, so we usually go to the right. Okay? So that's it. We're just going to restrict the domain. So that now, is this 1-to-1? That input, does it have one output? Does that one output only have one input? Yes. And so we would restrict that domain to make it a 1-to-1 function so that we can get the inverse. I guess I should make that note here. So we can get the inverse function. And if I were you, I would draw it a little sketch, either there on the back of the sheet, probably with a parabola, because that's the most common one that we have to restrict. So like, here, that's an ugly parabola. So that's not 1-to-1. So restrict domain. What would we restrict the domain to? For that sketch that I just created. So just 0? Just so remember, I want to take out all of this. Right? 0, so it starts at an x value of 0. What's the positive infinity is the maximum x. Now we can get an inverse. Right? So if I reflect across the line y equals x, anybody recognize that red function? It's the square root function, right? And that's why the square root function is the inverse, even though it only looks like half of parabolas, because we had to restrict the domain so that we could get a function. And I do want you to notice, see this domain of 0 to infinity? What's the range of this function? Oh yeah, because the x and the y switch. So what was the domain is now going to become the range. And so with this idea of inverse functions and logarithms and exponentials, we're going to get some practice identifying domain, range, decrease, increase, all that stuff again. Someone did ask, and first, well, Mr. Kinney, are you going to put this on the test? I will say this. Restricting the domain is not as big a priority for me as identifying if functions are inverses, or if I give you a function, you getting the inverse function for it. But this could be a good short answer question, right? In order for a function to have an inverse, it has to be a 1-to-1 function. Explain what that means and how that would work. Right? Does that make sense? Well, as a short answer, not as a calculation or non-calculated portion, right? So, and I will point out, 1-to-1, as I already told you, that's a big idea graphic organizer term, isn't it? Those things show up on the test pretty consistently. Alright, so we're only going to do one question off of this to start, and then I will say that because of the lack of time that we have, I will not be collecting this as a grade, but this stuff will show up on understanding checks and on test. So I will give you time to ask questions in class over the next couple of days from this thing.
We got another understanding check coming up.
We will have one on Thursday for everything we've covered through then, and then the test on Monday. So, with this sheet that I just passed out, I can determine if using the original function or an inverse function, or if we're dealing with data model, is best for answering a real world question, and also we want to be able to use models to answer questions. So, please note that this question here is based on task 2 from lessons 3 and 4. You may want both of those lessons out to look at. Detective Benoit Blanc, if you haven't seen Knives Out, by the way, it's Ryan Johnson's movie, you should, fantastic movie, but Detective Benoit Blanc has been called to a car wreck to investigate the claims of the person at fault. Very quickly, Detective Blanc notes that the person at fault left skid marks 120 feet long. Using your model from speed versus stopping distance, is there evidence that the driver was speeding in the 25 mile per hour speed zone? Well, this is why we might want a function, or the original function and its inverse. Because what was the function that we dealt with earlier? I think Caleb's original function was f of x equals 0.33 x minus 0.28 squared. That was the original. The inverse for Caleb was that g of y is equal to the square root of y plus 0.28. Yeah. And so I would also probably make the note, right, that y is equal to f of x and x is equal to g of y. So when we look at this information that the person left skid marks 120 feet long, what can I do with that 120 feet to figure out if they were speeding or what their speed was?
Divided by 8.
So that could be something I substitute in, right? For what?
X.
Why do you think x? Well, why do you assume it's the input? Why couldn't it be the output?
Because we're trying to find out what was
A lot of times when you're trying to find something out, if you don't plug it in for the X, I'm not gonna lie.
But sometimes you can plug it in for the y. But, so it depends on cause and effects, but that's why it's important. We did this in lesson 3. You have, lessons 2 and 3, you have to define the variables, right? Did the stopping distance depend on the speed, or did the speed depend on the stopping distance?
Oh, no,
think
no,
so.
the opposition depends on
Yeah,
speed.
how long it takes you to stop depends on how fast you're going, doesn't it?
Yeah.
That's how we defined it originally. Also, look at the way I set it up. Speed comes first, meaning it's the cause, the x, and the stopping distance is the y. Well, in both of these equations, we have a y, right? 120 is going to get substituted in for, how was it?
No, that's a lot.
Yeah, isn't that stopping distance?
Oh, yeah.
5.
Well, remember, we're trying to figure out if he's speeding. We don't know if he was going 25.
25 is speed.
The question was he speeding, right? But we know he was going, it took him 120 feet to stop. So we know that that's going to get substituted in for y. Notice, I could use either equation, can't I? Okay, so if I'm using the top equation, I'm going to get 120 equals 0.33 x minus 0.28 squared. and I'm gonna have to figure out what x is. If I use the bottom equation, I get x equals the square root of 120 plus 0.28 times 1 divided by 0.33. You can use either one. But if you're trying to figure out, hey, don't forget your x in there, Keyshawn. But if you're trying to figure out how fast this person was going, which of those equations would be easier? The top
You have
one?
to then see if they were equal to the speed or over speed. And
You
so
wanna
they
know
were
the
below
speed.
it, equal or over.
Hold on. Because you're trying to find out if he was speeding at 25.
You use the
Just trying to
bottom
find
one.
out the speed, see if it's over 25.
We're just trying to figure out the speed. You gotta remember that. I'm just trying to figure out speed. Which of those two equations, is it gonna be easier to figure out speed, what the x is equal to?
I see. I don't see it.
Trying to bottom.
Yeah, I said bottom too.
If I'm looking at the
I
top
said
one,
top.
I'm gonna have to use inverses, right?
Yeah, so you use bottom, you can say.
In the bottom, do you have to use any inverses?
No.
No. Remember, the inverse function literally has already had every inverse applied. Notice, Jakeem, if I'm solving this equation, what's the first thing I'm going to do to solve this equation? Take a, wait, I already have the square root. After I take the square root, I'm going to add 0.28. Oh, I've already added 0.28. And literally, you see how this equation says x equals? So the speed is equal to this. This is a big reason why we want both the original function and the inverse function, because I just need to figure out what x is equal to, or I need to figure out what y is equal to, so I substitute into the correct equation, so I just have to simplify, right? And so what I would say here, I haven't finished, but I would use this equation, but having both the original function or model, but having the original function and inverse function is useful because you're laughing about Xavier already asleep? I don't know. What are you laughing about? Is useful because it's easier to substitute y'all good?
Yeah.
And simplify rather than, and so I would make the note, bottom equation. You'll know that EQM stands for what?
Equation.
Okay, good. Substitute in and simplify the bottom equation rather than substitute and solve. Now, and once again, you have to know what the variables stand for, right? And you have to know what you're trying to solve for, you have to know what the value you have that you can substitute in is, but it is super, super useful having both functions, because it's just easier to substitute in and simplify.
The x is the cause, right?
Say it again?
The x is the cause, the y is the event.
Well, the x is the independent variable or cause, the y is the dependent variable or the effect,
Okay.
right?
I messed it up in my understanding shit.
I know. But that's why I give you feedback, we learn, we grow, and we improve. I'll give those back at the end of the class, because again, even if you made a 20 on the understanding check, you learn from it, you make an 85 on the test, you have an 85.
I need all of the draw.
Hey, make no
Hey,
choice.
probably like a 20.
There it goes.
You miss a lot of school and you sleep the other days, bro. You gotta stay awake.
Any other class, I try to go to sleep. I go to sleep.
You might have an
No, I try to stay up though.
Okay? So, go ahead and I want you to substitute do that bottom equation, figure out what the speed was to answer this question. And personally, I would point out, can you just put all that into the calculator all at once? Just be careful with your parentheses and stuff. You can.
Don't forget that.
There is no hat this time, bud.
Oh, you gotta put this in
No, it's understood that it's an estimate, but also like, we're not solving for y hat, we're solving for x.
33, 34,
So 33, 34 miles per hour?
34, 34.
Say what was it?
So was he speeding?
Yeah.
Zoom.
It's probably in a residential area, moving a little too fast.
That ain't that.
But,
I'll be doing 100.
but when the speed limit is 25,
Man, what the speed limit is? You might have road settle how fast you go.
Like, on, right there, out there, and at nighttime, oh, stop at no stop sign. Out there. What?
Oh, no, you gotta stop the stop sign.
No.
I don't ever want to hear anyone ever complain then when a police officer pulls you over because you're being dumb on the roads.
Oh, damn.
Okay, so about 34 miles per hour. So, yes, we would want to note that he is speeding. So we're not going to go through all the rest of these, but the big thing to note is make sure you identify what your original function would be, what your inverse function is, and then which one's going to be easier to substitute in for. Yes, sir?
Some can.
Easy.
Had to
I'm
stop.
standing on brakes real hard, you ain't skid my anyway.
Yeah, sure.
Like,
Man, you can make skid marks with a bike, bro.
120 feet's nothing.
Bro, you can make skid
and
marks
put
with
that
a bike.
rain.
Think about it, that's only what, 40 yards? That's nothing.
I ain't even make skid marks, I really can't, I ain't even had time to break.
Bro, you can make skid marks.
I don't think that that's something to brag about. Alright, so please note these other three questions. Hey, look guys, these other three questions, I highly recommend that you try. You will have time to ask questions in class. These things will be on the understanding check in the test. I'm not going to collect it for a grade. So at least try it to figure out what questions you need to ask or to check yourself. Okay? So I'll have solutions for them. Alright, so now we're getting to the stuff from the textbook. Woo!
No!
So, we've been learning about what types of functions?
Inverse.
Inverse functions. That is to parlay directly into the special type of function function its inverse exponential, and the inverse of an exponential is a logarithm, right? Now, there are infinitely many logarithms out there.
Natural.
Natural is one of them.
No, natural.
Not non-natural.
Look at this.
Okay? So let me point this out, right? When it was a natural log, what base did we put on the exponential function? Do you remember? It was e, right? So natural log of x, we did e raised to the x. So what if it was log base 2 of x? What do you think we would do then?
E to the 8 squared.
So one thing I
E squared.
E squared to the y.
not e squared to the y.
E
So
squared to the 8.
hold on.
Oh,
Hold on.
square root of e to the y.
Y'all, stop. Stop. One thing I want to point out here is this. The natural log really is just log base e of x. It's just so common that we use ln. So if log base e of x becomes e to the x for the inverse, what's going to be the inverse for log base 2 of x?
E squared to the 8.
2 equals.
What's the only reason that e is right here? Because it was base e. There is no e anymore.
Oh, 2x
So 2
to the 8.
to the x. What about log base 10?
10 to the 8.
10 to the x. So what if you had 13 to the x? What would be
It would be log 13.
log base 13x? Okay? Very quickly, we want to notice that the base stays the same, right? And so we're going to talk more about what this logarithm means moving forward, but one of the things that we need to learn about is this number e. Where in the world does e come from? And so we've already discussed, I think, that e is roughly what number? 2.71828, and it just keeps going after that. It's a lot like pi in that it's irrational, okay? So we're going to get as far as we can with this lesson 2. And we are going to focus here on domain, and so please note, we are only looking at exponential functions to start, and then tomorrow we'll start in logarithms specifically, but I want us to understand where the number e comes from. First things first, summarize the characteristics for the basic exponential function. We are going to skip in behavior because we're not going to talk about that. Asymptotes is something that I will tell you about. Actually, let's just go ahead and define asymptote, and then we'll see if you can figure it out. I'm going to send you out a file where it has a function f of x equals b to the x, and b has to be greater than 1. I'm going to have you use a slider to move it around and see if you can figure out what these characteristics are of these functions. But an asymptote is a line or curve that a function, I guess really just a relation, but I'm going to say function for now, that a function approaches, that keyword is approaches, at some infinity. Okay? So an asymptote is a line or a curve that a function approaches at some infinity.
And basic exponential.
Say it again?
Basic exponential, right?
Well, that's just asymptote in general. We're going to look at basic exponential growth versus basic exponential decay. Okay? But that just needs to go next to what an asymptote is. Okay?
Yo, Mr. Kenny, turn on the look
Where'd you hack it? Bring it jacket. Yeah, hide outside it. Well, you're inside. Take the jacket off when you go outside.
It's like, I feel like carrying this jacket around.
You could get a normal backpack, normal size backpack, and put it in there. Alright, so what I've already done is I sent out a file to your calculator, and I want you to notice that this file has a slider on there for the value of b, right? So you have the function b raised to the x, and to start we're looking at exponential growth. How do we know that this is a growth? So it's, what's a mathematical term for that?
It's increasing.
It's what?
It's always increasing.
It's always increasing. And so notice we don't want b equals 1, right? That's not an exponential function. We want b greater than 1. So play around with it and see if you can figure out what the domain and range of every exponential function when it's an exponential growth would be. And then look at the other features. We'll discuss in a minute, but I need you actively engaging and discussing. Well, what do we mean by domain? Well, would it be different or are they all the same for the domain? Say again. No, you're in first block, bud. Or you're in second block. Document 5. That one. But you're missing the question, Jakeem. I'm asking you, what is the domain? Does the domain change for any of those exponential functions?
It seemed like one of the first one.
The domain is
The what?
Caleb.
I don't know, just doing.
I don't know.
What do we mean by domain? It's the set of all what? So what is the minimum x values for every single one of those exponential functions?
This one.
Well, remember the minimum, Jakeem, the minimum x, not the y, the x. Look at it right here. What is the lowest x value? Is everybody stop?
Yeah.
So the lowest x is negative infinity. What's the largest x value? Not the fact that it's going up, but the fact that it's going to the right. So what's my domain? right? What's the range?
One positive infinity.
Zero, negative infinity. I mean, zero infinity.
So what is the lowest y value?
Zero.
So there's a y value of 1, it never goes below that?
It does. His
It does.
go below the
It never goes below the x-axis, and it never gets to the x-axis. So the lowest is 0.
Zero positive.
Now, remember, we put parentheses when we cannot equal the value. We put a bracket when it does equal the value. We just said it never actually gets to the x-axis. So does it ever actually get to 0? No, so I need a parentheses. Right? So there's my domain and my range. At least for the exponential growth. Any guesses what the asymptote would be? Based on how we defined that earlier.
Is it 1? Where is it 0?
Well, it doesn't need to be greater than 0. Remember, it's just a line or a curve that a function approaches. It gets close to. Doesn't actually get there, but it gets close to it. It gets close to what? What value gets close to 0? The y. Remember, it's the x-axis, right? But what is the y value of every point on the x-axis? It's 0. So the asymptote would be y equals 0, the x-axis. That is what that exponential curve is approaching as x goes to negative infinity. Okay? This is under exponential growth, yeah. Yeah, I would flip back and forth, but I want you to be able to look at that graph. Caleb, how's your leg doing?
Good.
Yeah? Are you clear to play yet, or are you still?
Yeah, good.
Okay. That's pretty good, quick recovery, relatively.
Quick now.
Mhm.
We ready.
So this is all for the exponential growth, domain, range, asymptote. What comes next?
Increase? Yeah. Increase.
There's nothing before that after asymptote?
Intercepts.
Intercepts. Anybody have an idea about intercepts?
Which we,
What are the intercepts that we could have?
We got y-intercept, -0, comma 1.
Yeah, every exponential growth is 0, 1.
Yeah.
Okay, what about an x-intercept?
Well, no.
Yeah, remember how we said it approaches the x-axis, never gets there. Could be not.
They find it.
It doesn't sound like it. Sounds like someone did really well. Alright, so remember I told you, don't worry about in behavior.
Interval to decrease and increase.
Yeah. Interval of increase or decrease, what is it? Come on.
It starts increasing.
So it's increasing. It's literally called a growth.
Negative infinity.
You don't decrease at all.
It doesn't decrease at all, so, and don't forget, it only says interval of increase or decrease, but I always called it a domain interval, because we want to be very intentional. The only values that we put are what kind of values? X, thank you. So, where does the x value start increasing? At negative infinity. Where does it stop increasing?
Positive.
And so it really doesn't, it just goes all the way to positive infinity. Now I want you all to do it on your own for the exponential decay. I'm going to send you another file that I want you to try to talk this out through.
It'll be the opposite. This one is.
Dang, what if you right?
What if he's right?
Dang.
Here's the thing though. Can you ever make a claim without evidence?
No.
Make sure that you look for evidence.
Man, you can't give my hope. Thank you.
Notice you needed, for an exponential decay, you needed values between 0 and 1. So, talk it out.
So instead of it,
Ah, move it.
You get a whole.
instead of it approaching to the,
Say again.
then you say, what's the asymptote, it approaches to the y.
Well, I just said, well, last time it was the x-axis, y equals 0, but in general, an asymptote is a line or a curve that a function approaches at some infinity.
It doesn't say, would it be the same thing for decay?
What do y'all think? Would the asymptote still be y equals 0?
Yeah.
It's approaching the x-axis, isn't it?
Mm-hmm.
Okay.
And the domain is positive infinity, negative infinity.
What do y'all think about that?
Yeah. Oh.
I need you to pause and remember. In interval notation, minimum first, then maximum. It doesn't matter
So
how it
negative
appears.
is positive infinity.
It's still a minimum of negative infinity and a positive of positive infinity, or a maximum of positive infinity. So it's still negative infinity to positive infinity
For the what?
for the domain, right? You always go negative to positive, or minimum to maximum every single time.
So same thing for range, we gotta go. Well, range go one to negative infinity.
Y'all agree? Ranges from 1 to negative infinity?
Well, we still gotta go one.
It's always still minimum
So
to
negative
maximum.
infinity to one.
Zero to negative.
What is the minimum y value? 0. Yeah, we're asking about range.
I put it, infinity is 0.
But Preston, remember, we just talked about the fact that it has to be a minimum first.
So negative infinity is 0.
Does the y go down to negative infinity? What is the lowest y value?
0 to negative infinity.
I would agree 0 is the lowest y value, but what's the maximum y value?
Oh,
It's going up, isn't it? So it's positive infinity. You gotta slow down, because a lot of students, and so Preston, what you probably did is you looked from left to right, didn't you? But left and right is a domain idea. When we're talking about range, we're looking at up and down. And you start, the lowest would be the furthest down, the highest would be the furthest up. Does that make sense?
So I'm going for that.
Correct. Yeah. Does that make sense now? Okay. Y-intercept then?
0.
0,
0, 1. X-intercept?
1, 0.
Does it intersect the x-axis at 1, 0?
nope.
About 15, 20 minutes.
Domain interval of decrease? Or increase?